Hello everyone, good evening. So here we shall solve some more JEE mains previous year questions on the chapter units and measurements. So any doubts if you have, please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also please install our Sapience education application where we shall upload some important homework questions on every chapter of physics, which shall be obviously helpful for your exam. And also in any other chapter of physics, if you have more difficulty, please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Okay, so here it is told a cylindrical wire of mass 0.4 plus or so the mass of the wire is 0.4 plus or minus 0.01 gram, and the length of the wire that is 8 plus or minus 0.04 centimeter, and the radius is 6 plus or minus 0.03 millimeter. Then the maximum error in its density will be. So the density of the cylindrical wire, so we have a cylindrical shaped wire. So the density will be, as you know, that will be equal to mass by volume, and volume of a cylinder that we know that is equal to pi r square into L, where L is the length of the wire. So that will be m by pi r square into L. So therefore, the percentage error in finding the density, that is delta rho by rho into 100%, that will be equal to delta m by m into 100%, that is the percentage error in the measurement of mass, plus here r square is there, so it will be 2 into the percentage error in the radius, then plus percentage error in the measurement of the length. So therefore, the percentage error in the measurement of density, that will be equal to the percentage error in measurement of mass, that is equal to 0.01 by 0.4 into 100%, plus this will be 2 into delta r by r, that is 0.03 by 6 into 100%, plus delta L by L, that is 0.04 by 8 into 100%. So that will be, so this will be 1 by 0.4% plus this is 3, that is 6 by 6%, which is 1, plus this will be 4 by 8%, which is half. So this is 10 by 4, that is 5 by 2%. Plus 1% plus half percent. This is 6 by 2, that is 3%. So this is 4%. So 4% is the maximum error in its density. So option C is the correct answer. Then here it is told two resistances are given as R1 equals to 10 plus or minus 0.5 ohm and R2 that is equal to 15 plus or minus 0.5 ohm. Then the percentage error in the measurement of equivalent resistance when they are connected in parallel is. So R will be equal to R1 R2 by R1 plus R2. You can also say that the equivalent resistance 1 by R, that is equal to 1 by R1 plus 1 by R2. So if we differentiate both sides, then we'll get dr by minus 1 by r square into dr, it is minus dr by r square equals to minus dr1 by r1 square minus d r2 by r2 square. So therefore we can say that delta r by r, that will be equal to r into, let's say, delta r1 by r1 square plus delta r2 by r2 square. Since the error is very small, so we can take dr as approximately delta r, where delta r is the absolute error in the resistance. So now therefore r, that will be equal to, now r1 has been told that is equal to 10 plus or minus 0.5 ohm, and r2 is 15 plus or minus 0.5 ohm. So therefore r will be equal to r1 r2 by r1 plus r2, that is 25. So this is 5 to the 10, 5 5 is 25, 5 3 is 15, so that is equal to 6. So equivalent resistance is 6 ohm, and delta r1, that is same as delta r2, that is the absolute error in finding the resistance, that is equal to 0.5 ohm. Now therefore we have to find the percentage error in the measurement of equivalent resistance, means delta r by r into 100, that we have to find. So that will be equal to r, which is 6 ohm, into delta r1, that is 0.5, by r1, that is 10 square, plus delta r2, that is also 0.5, by r2 square, that is 15 square. So this much into 100%. So that this will be equal to 600 into 0.5 into 1 by 100 plus 1 by 225. Since y 15 square means 15 5 is 75, so it is 225. This much percent. So this will be equal to 0.5, so it is 300. 300 by 100 plus 300 by 225. So this will be 0 0 will cancel, so this is 3. 15 15 the 225, 15 to the 30, and 5 3 the 15, 5 4 the 20. So it is 3 plus 4 by 3, so that is 3 3 the 9, 9 plus 4, that is 13 by 3%, or I can say that means approximately 3 4 the 12, 4 whole 1 by 3%, means it is approximately 4.33%. 4.33% is the percentage error in the measurement of equivalent resistance when they are connected in parallel. So option C is the correct answer. And here it is told, if the velocity of light c, universal gravitational constant g, and Planck's constant h are chosen as fundamental quantities, the dimension of mass in the new system is. So C is the, so C, G, and H are chosen as fundamental quantities, then the dimension of mass in the new system. So therefore we can say mass is proportional to C power some constant x, then G power y, and H power z. So then if we can find the powers of C, G, and H, which is x, y, and z, then only we can find the dimension of mass. Therefore, the dimensional formula for mass, that is same as the dimensional formula of C power x into dimensional formula of G power y into the dimensional formula of H power z. Now, the dimensional formula for speed of light, that is same as the so the dimension formula for velocity of light, that is length by time, so it is LT power minus 1, and the dimensional formula for capital G, that is equal to F R square, there is F R square by M square, so that will be equal to force, that is MLT power minus 2 into L square divided by M square. So therefore that will be equal to m power minus 1 L cube T power minus 2. And Planck's constant h that we know that is equal to lambda times p, since lambda equals to h by p. So the dimensional formula for Planck's constant is lambda into p, where it is wavelength into linear momentum. So wavelength dimension is L, and for linear momentum the dimensional formula is mass into velocity. So this will be ml squared t power minus 1. So now therefore the dimensional formula for mass, that is m, so that should be same as c power x, which is L t power minus 1 whole power x into g, that is m power minus 1 L cube t power minus 1, sorry, t power minus 2 whole power y into h is ml square t power minus 1 whole power z. So now this we can write it as m power minus y plus z into L power x plus 3y plus 2z into t power minus x minus 2y minus z. So then the exponent of m is 1, so therefore z minus y, that should be equal to 1, and x plus 3y plus 2z, that should be equal to 0, and x plus 2y plus z, that should be also equal to 0. So z is equal to y plus 1. So this is equal to 0. So therefore if we subtract these two, then therefore we will get y plus z, that should be also equal to 0. So therefore 2y plus 1, that should be equal to 0. So y should be equal to minus half, and z should be equal to minus of y, which is half, and x we have to find out. So x will be equal to minus 2y minus z. So that should be equal to minus 2 into minus half minus half. So this will be 1 minus half, that is equal to half. So x will be equal to half. So therefore m, the dimensional formula for m, that is equal to h power half y is minus half, h power half c power x is also half. X and z, they are half, but y is minus half. So it will be c power h power half c power half into g power minus half. So option C is the correct answer. Then here it is told to find the dimensions for angular momentum, torque, stress, and pressure gradient. So the dimensional formula for angular momentum, that is, let's say L1, that is equal to R cross P. So therefore it is length into momentum. Length is L and momentum is mlt power minus 1. So therefore the dimensional formula for angular momentum is ml square t power minus 1. Square t power minus 1. So A matches with 3. So now torque is equal to R cross F. So therefore the dimensional formula is force into length. So it is ml squared t power minus 2. So it means that B matches with 1. A matches with 3 and B matches with 1. So it means obviously option B is the correct answer, but still we can verify the part C and D. So C is stress. The formula for stress is force by area. So its dimension will be ml power minus 1 t power um, m- minus 2. So it means that C is fourth one and D is pressure gradient. A pressure gradient, it means it is dp by dx, which is pressure by length, which means it is change in pressure by change in the length. I can also say it as delta p by delta x. So pressure is force by area into delta x, which is the length. So this will be force, which is mlt power minus 2 by area, which is L square, and length is L. So it will be ml power minus 2 t power minus 2. So option 2. So D will match with 2. So obviously option B is the correct answer. And here it is again told to find the dimensional formula for torque. No, we have to find the SI unit of torque. So for torque, the SI unit is, it is R cross F. So it will be force, that is Newton meter, and Newton, as you know, it is kg meter per second square into meters. So its SI unit, I can say kg meter square per second square. So A will match with 4. Then B is the energy density. Energy density. So energy density means energy per unit volume. Energy by volume. So energy SI unit is joule. Joule per meter cube. Or I can say joule is, it is actually kg meter square per second square into meter power minus 3. So that will be kg per meter per second square. So this is the SI unit of energy density. So obviously B will match with 1. B matches with 1. And then we have to see the part C. C is pressure gradient. And so the pressure gradient, it means it is the change in pressure by change in the length. So I can say it will be force by area times the length. So it means it will be kg meter per second square divided by meter cube. So therefore its SI unit will be kg per meter square per second square. Kg per meter square per second square. That means that C matches with 3. C matches with 3. Then impulse. Impulse is change in momentum. Change in momentum is called as impulse. It is force, and into time. So it is kg meter per second. So it means D will match with 2. So it means that option A is the correct answer. And here it is told the equation of a circle is given by x square plus y square equals to a square, where a is the radius. If the equation is modified to change the origin other than 0 comma 0, then find out the correct dimensions of a and b in the new equation. The dimensions of t is given as t power minus 1. Okay. So here, so the dimension of AT, that is same as the dimension of x. X is the length. Since x is the x coordinate, so it is obviously the length. So A, so the dimension of A will be the dimension of x by t. So x is the length by t. T is t power minus 1. So it means that the dimension formula of A is equal to LT. And then the dimension formula for t by b, that is same as y. Now y is also some sort of length. So t is t power minus 1 divided by b, that will be equal to the length. So therefore the dimensional formula for b is t inverse divided by length. So that will be L inverse t inverse. So b is L inverse t inverse and C is A is LT. So option C is the correct answer. Then here it is told match least one with least two. Now here the pressure gradient, pressure gradient. So that is given as change in pressure by change in the length. So that is delta P by delta X. So it is simply, you can say its dimension will be same as pressure by length. So it is force by area into length. So therefore, the dimensional formula for pressure gradient, that will be equal to force, that is ml t power minus 2 divided by L cube. So this will be m L square L minus 2 t power minus 2. So A matches with 3. And B is energy density, which is energy by volume. So we can say force into length, which is same as the dimension of the energy per unit volume, which is L cube. So it means it should be F L power minus 2. So force is M L T power minus 2 into L power minus 2. So this will be M L power minus 1 T power minus 2. It means that B will match with 2. And then C is electric field. The dimensional formula for electric field. So the electric field, that is actually the electric force divided by charge. Force is mlt power minus 2 divided by charge. Charge is current into time. So it is A into T. So this I can say this will be ml A power minus 1 T power minus 3. So C will match with 4. C will match with 4. And D, which is the latent heat. So latent heat means it is equal to the heat by mass. Heat energy divided by mass. So heat energy is same as, its dimension is same as the work done, which is ml square T power minus 2 divided by m. So this will be equal to m power 0 L squared t power minus 2. That means D matches with 1. So it means that option A is the correct answer. And here it is told to find the dimensional formula for Young's modulus. So the dimensional formula for Young's modulus is same as the dimensional formula for stress. Since why strain has no dimension. Since Young's modulus is stress by strain, strain has no dimension. So it means the dimensional formula for Young's modulus is same as that of the dimensional formula for stress, which is force by area. So it is mlt power minus 2 by L square. So that will be ml power minus 1 t power minus 2. So it means that A will match with 3. A will match with 3, and B, which is the coefficient of viscosity, the coefficient of viscosity, that is equal to the viscous force by 6 pi rv. Since why viscous force is 6 pi eta rv on a sphere, which is, if a sphere is moving through a fluid, then this amount of viscous force is exerted against this force is exerted by the fluid on the sphere. It means that the dimensional formula for eta is the dimensional formula of force by r into v. So this will be ml t power minus 2 divided by L square t power minus 1. L square t power minus 1. So L will cancel out. Then the dimensional formula for eta, that will be m L power minus 1 t power minus 1. So then B will match with 1. Then we have Planck's constant, which is h. So h, Planck's constant, will be lambda times p. So therefore the dimensional formula for Planck's constant is length into mass into velocity. So this will be ml square t power minus 1. It means that C will match with 2. C will match with 2. A3, B1, C2, and then D, which is the work function. Work function, that is phi. Phi is equal to, phi is same as the energy only, since in the Einstein's photoelectric effect, we know that h nu equals to h nu naught plus kinetic energy. And this h nu not only is called as phi naught, which is the work function. So it means that its unit is same as the energy. It is same as the energy only. So therefore the dimensional formula for phi naught, that will be equal to energy, dimension of energy is same as that of the work. So it is force into length. So it is ml square t power minus 2. So it means that D will match with 4. D will match with 4. So it means that option D is the correct answer. A3, B1, C2, and D4. Option D is the correct answer. Then here we have to find the Dimensional formulas for Planck's constant. Planck's constant is lambda into P. So its dimensional formula will be ml squared T power minus 1. And the dimensional formula for stopping, the dimensional formula for stopping potential, that is your Vs. Stopping potential or Vs. So that will be equal to, so as you know, EVs equals to the energy. So which is equal to energy divided by charge. Okay. It's energy divided by charge. So that will be equal to energy divided by current into time. So energy is ml squared T power minus 2 divided by I, which is A to T. So this will be ml square T power minus 3 A power minus 1. So it means that Planck's constant, which is ml squared T power minus 1. So A matches with 3 and B matches with 4. So it means obviously option B should be the correct answer. But still we can check C and D parts. For C, that is work function. Work function phi naught, it is having the unit of the energy only. Phi naught, that is the ml squared T power minus 2. ml squared T power minus 2. So option 1. So it means C matches with 1. And D is momentum. D is momentum. So its dimension is mass into velocity, which is ml T power minus 1. So option 2. So D matches with 2. So option B is the correct answer. So here it is told that in a screw gauge there are 100 divisions on the circular scale, and the main scale moves by 0.5 millimeter on a complete rotation on the circular scale. The zero of circular scale lies 6 divisions below the line of graduation when the two studs are brought in contact with each other. When a wire is placed between the studs, 4 linear scale divisions are clearly visible, while 46th division uh, on the circular scale coincide with the reference line. The diameter of the wire is. So therefore, we can first find out the least count of the screw gauge. Least count of the screw gauge, that will be equal to the pitch of the screw gauge divided by the number of divisions on the circular scale. Yeah, so the pitch is 0.5 millimeter divided by 100. So that will be 0.005 millimeter. This is the least count. Now therefore the zero error we have to find. Zero error will be here. The zero of circular scale lies 6 divisions below the line of graduation. So the zero error will be 6 into the least count. That will be 6 into 0.005 millimeter. So that is 0.03 millimeter. So when a wire is placed in between the studs, 4 linear scale divisions are clearly visible. So here, therefore, the observed reading, first we have to find observed reading, that is equal to the main scale reading plus vernier scale plus circular scale reading. Now the main scale reading is 4, where is placed between the studs, 4 linear scale divisions are clearly visible. So 4 millimeter plus circular scale reading 46 into 0.005. So that will be 4 millimeter plus I can write 23 into 0.01 millimeter. So this is 4.23 millimeter. Now, therefore, the zero error, that is 0.03 millimeter. So therefore, the actual reading, that is the diameter of the wire, that will be equal to the observed reading minus zero error. So that will be equal to observed reading, that is 4.23 millimeter minus 0.03 millimeter. So that is 4.2 millimeter. So therefore, the diameter of the wire therefore the diameter of the wire is, I can write 420 into 10 power minus 2 millimeter. Here actually the least count of the main scale is 0.5 millimeter. So 4 linear scale divisions, I think it will be 4 into 0.5. So this will be 2 millimeter. This will be 2.23. So this will be 2.2. So this will be 220 into 10 power minus 2 millimeter. So this is the answer. Then here it is told, choose the correct answer from the options given below. The dimensional formula for torque, that is force into the length, that will be ml square t power minus 2. And the stress, the dimensional formula for stress, that is force per unit area, so that will be m L power minus 1 T power minus 2. And latent heat, the dimensional formula for latent heat, that will be heat by mass. So heat energy, that is ml square T power minus 2 by m. So that will be L square T power minus 2. So here actually we have to find the SI unit. So for torque, it will be Newton meter, and for stress, that will be Newton per meter square, and for latent heat, that will be Joule per kg, and power, that is work done by time taken, or work done by time, or I can say force into velocity. So that will be, its unit will be Newton meter per second. So it means A will match with 3, B will match with 4, C will match with 2, and D will match with 1. So 3, 4, 2, 1. So option B is the correct answer. Then here it is told time period of oscillation of liquid drop depends on surface tension. If density of the liquid is rho and radius of the drop is r, then T equals to K into root over rho r cubed by S power 3 by 2. Is dimensionally correct when K is dimensionless. So the reason is during using dimensional analysis, we get RHS having different dimension that of time period. So we have to check if the equation is dimensionally correct or not. So in the left hand side, we have time period. So its dimensional formula is T for time period. And the dimensional formula for K square root of rho r cube divided by S power 3 by 2. So that will be equal to so this will be equal to the so K is dimensionless, they have told. So the dimensional formula of rho is rho dimensional formula for rho into dimensional formula for r power 3 by 2 divided by dimensional formula for S power 3 by 4. So now dimensional formula for density, that is mass per unit volume. So ml power minus 3 into L power, no, recording. I don't know. Yeah, yeah. Means I forgot. I forgot. One second. So here it is rho is m L power minus 3 whole power half, obviously. And R it is L power 3 by 2 divided by S. S is force by force per unit length. So that is F, that is ml T power minus 2 by length whole power 3 by 4. So that is this is m power half minus 3 by 4. L will cancel. This is into L power minus 3 by 2, then plus 3 by 2, then into T power 3 by 2. It means that this K should not be dimensionless. Since why here m power minus 1 by 4 is also coming into T power 3 by 2 is coming. So it means that the right hand side is not coming the dimension of time period. So it means R is true and A is also true. R is true So A is false since K should not be dimensionless. So A is false, but R is true. So option D is the correct answer. And here it is told a traveling microscope has 20 divisions per centimeter on the main scale, while its vernier scale has total 50 divisions. A traveling microscope has 20 divisions per centimeter. So it means one main scale division is 1 by 20 centimeter, means it is 0.05 centimeter. And its vernier scale has total 50 divisions and 25 vernier scale. So the number of vernier scale divisions is 50 and 25 vernier scale divisions, that is equal to 24 main scale divisions. So therefore one vernier scale division, that is equal to 24 by 25 main scale division. Then what is the least count of the traveling microscope? So the least count, that will be equal to one main scale division divided by number of vernier scale divisions, that is equal to 0.05 centimeter divided by 50. So that will be 0.001 centimeter. Or we can solve it like this also. One vernier scale division, that will be 24 by 25 into 0.05. So that will be 48 by 50. That is 0.048 centimeter. So it means this one we cannot use, since least count will be one main scale division minus one vernier scale division. So that will be 0.05 centimeter minus 0.048 centimeter. So this will be 0.002 centimeter. So option C is the correct answer. Then here it is told in an experiment to find out the diameter of the diameter of wire using screw gauge, the following observations were noted. Screw moves 0.5 millimeter on main scale in one complete rotation. Therefore, the pitch is 0.5 millimeter. The total number of divisions on circular scale is 50. So therefore, the least count, that will be 0.5 millimeter divided by 50. So that will be 0.01 millimeter. So this is the least count of the screw gauge. And main scale reading is 2.5 millimeter. 45th division of circular scale is in the pitch line. Instrument has 0.03 negative error. 0.03 millimeter negative error. Okay. So therefore the circular scale reading, that is 45 into the least count, that is 0.01 millimeter. So that is 0.45 millimeter. So therefore the observed reading, that is equal to observed reading, or I can say that is the calculated reading, that is main scale reading minus plus circular scale reading. So main scale reading is 2.5 millimeter plus 0.45 millimeter, that is 2.95 millimeter. And the instrument has 0.03 millimeter negative error. So therefore the actual diameter of the wire, that is equal to the observed reading minus the zero error. Now observed reading is Observed reading is 2.95 millimeter minus the minus 0.03 millimeter. Since why it is told it is negative zero error. So therefore, this will be equal to 2.98 millimeter. So 2.98 millimeter is the diameter of the wire. So option C is the correct answer. Then here it is told, consider the efficiency of Carnot's engine is given by eta equals to alpha beta by sine theta into log base E beta x by kt, where alpha and beta are constants. If T is the temperature, K is the Boltzmann constant, theta is the angular displacement, and x has the dimensions of length, then choose the incorrect option. So dimensions of beta we have to find. So it means the dimension of the term which is under, which is inside the log, that should be dimensionless. So beta x by kt, that should be dimensionless. That should be equal to m power 0, l power 0, t power 0. Now it means the dimensions for beta, that should be same as kt by x. Now kt means it is the kinetic, the the thermal kinetic energy. Here k is Boltzmann constant. So it is ml square t power minus 2, which is the dimension for energy divided by length l. So it is same as the dimension for force, which is mlt power minus 2. So dimensions of beta is same as that of force, and dimensions of alpha we have to find. Now efficiency will be dimensionless, since by efficiency is output energy by input energy. So alpha into beta should be dimensionless. So therefore it should be m power 0, l power 0, t power 0. So the dimension of alpha, that is the reciprocal of the dimension of force. Now therefore dimension of alpha inverse into x, alpha inverse x, alpha inverse is same as the dimension of force into x. So that will be same as the dimension of energy or work done. And dimension of eta minus eta inverse sine theta, this is also dimensionless, and alpha beta is also dimensionless, so that is same. Dimension of alpha is same as that of beta, so this is wrong, since alpha has the dimension which is reciprocal of beta. Reciprocal of beta has the same dimension of alpha. So option D is the incorrect statement. So D is the correct answer. Then it is told the dimension of beta square, the dimensions of b square by mu naught will be b square by mu naught will be. Now b square by 2 mu naught, it is called the magnetic energy density. Magnetic energy density. It means it is the magnetic energy per unit volume. So it means B square by mu naught will have the same dimension as that of energy by volume. So it means energy is ml square t power minus 2. It is the dimension of energy, and the dimension of volume is L cube. So if we solve it, then we will get ml power minus 1 t power minus 2. ml power minus 1 t power minus 2. So option C is the correct answer. Then here it is told an expression of energy density is given by U equals to alpha by beta sine alpha x by kt is the expression for energy density, which means it is energy by volume, energy per unit volume, where alpha and beta are constants and x is the displacement, k is the Boltzmann constant, and t is the temperature. The dimensions of beta will be now alpha by the dimension of alpha by beta, the dimension of alpha by beta, that will be same as the dimension of energy density, and the dimension of alpha x by kt, that should be dimensionless, that should be m power 0 l power 0 t power 0. So therefore the dimension of alpha, that will be equal to dimension of kt by x. It means it is energy by displacement, so it is same as the dimension of force, which is equal to ml t power minus 2. Now alpha by beta is same as the dimension of energy by volume. So therefore alpha by beta, its dimension, that is equal to energy by volume, which is ml squared t power minus 2 divided by L cube. Now therefore alpha has the dimension of force, which is ml t power minus 2 divided by dimension of beta, that is equal to ml power minus 1 t power minus 2. So therefore the dimension of beta, that is ml t power minus 2 divided by ml power minus 1 t power minus 2. So m will cancel, t will cancel, so this will be equal to L square. So dimension of beta is L square. So it means dimension of beta, I can say, that is equal to m power 0 L square t power 0. So it means option D is the correct answer. Then here it is told a torque meter is calibrated to reference standards of mass, length and time, each with 5% accuracy. A torque meter is calibrated to reference standards of mass, length and time with 5% accuracy. After calibration, the measured torque with its torque meter will have a net accuracy of. Okay. So torque, we know that the dimensional formula for torque, that is force into length, that will be equal to ml squared t power minus 2. So therefore the measured torque, so its accuracy, it means the percentage error in the torque, percentage error in the measurement of torque, that will be equal to percentage error in the measurement of mass plus twice of the percentage error in the measurement of length plus twice of the percentage error in the measurement of time. So therefore this will be equal to the mass, length and time each has 5% accuracy. So 5% is the percentage error in mass, 5% is 5% is the percentage error in length, 5% is the percentage error in time. So this will be 2 plus 2 plus 1, that is 5. 5 into 5% is 5 for the 25%. So the measured torque will have a net accuracy of 25%. So option B is the correct answer. Then it is told that in a vernier caliper, 10 divisions of vernier scale is equal to 9 divisions of the main scale. So 10 vernier scale divisions, that is equal to 9 main scale divisions. So 1 vernier scale division equal to 9 by 10 main scale divisions. When both jaws of vernier calipers touch each other, the 0 of the vernier scale is shifted to the left of the 0 of the main scale. And fourth vernier scale division coincides exactly with the main scale reading. One main scale division is equal to 1 millimeter. The 0 of the vernier scale is shifted to the left of the 0 of the main scale. Fourth vernier scale division coincides with the 0 of the vernier scale is shifted to the left of the 0 of the main scale. So there is negative 0 error. And one main scale division is equal to 1 millimeter. While measuring diameter of a spherical body, the body is held between two jaws. It is now observed that 0 of the vernier scale lies in between 30 and 31 divisions of the main scale reading, and 6th vernier scale division exactly coincides with the main scale reading. The diameter of the spherical body will be. So now the observed reading that we have to find. Observed reading is main scale reading plus vernier scale reading. So now, therefore, the observed reading that is equal to the main scale reading, which will be 30 divisions of main scale. So it is 30 millimeter is the main scale reading plus vernier scale reading is 6 into the least count. So now therefore the least count that will be equal to one main scale division minus one vernier scale division. One main scale division is 1 millimeter minus one vernier scale is 9 by 10 millimeter. 9 by 10 millimeter. So that is 1 by 10 millimeter, or I can say 0.1 millimeter is the least count. So 0.1 millimeter. So it is 30.6 millimeter is the least count. No, is the observed re re reading. Observed reading is 30.6 millimeter. And the zero error we have to find. The zero error that will be equal to fourth. Here it is told fourth vernier scale division coincides exactly with the main scale reading. Fourth vernier scale division minus of 10 minus 4 into minus of 10 minus 4 into 0.1 millimeter. So that will be minus 0.6 millimeter. So it is the negative zero error. So therefore, This is actually it should be a positive zero error. Something wrong here. So the zero error will be plus 4 into 0.1 millimeter, that is 0.4 millimeter. Therefore, the actual diameter of the wire, the actual diameter of the spherical body, that is equal to the observed reading minus zero error. Observed reading minus the zero error. So that will be equal to 30.6 millimeter minus 0.4 millimeter. So that is 30.2 millimeter, or I can say 3.02 centimeter. So 3.02 centimeters. So option A is the correct answer. And here it is told a screw gauge of pitch it is 0.5 millimeter. It is used to measure the diameter of a uniform wire of length 6.8 centimeter. The main scale reading is 1.5 millimeter, and the circular scale reading is 7. The calculated curved surface area of the wire to appropriate significant figures is. So the curved surface area of the wire, that was given as 2 pi r h, or I can say it is the pi dh, where d is the diameter of the wire. Pi dh. Now, where h is the length, I can say pi dl, I can say L is the length of the wire. Length of the wire is 6.8 centimeter. And pi, I can take pi is 3.1416 approximately. And therefore, the screw gauge has 50 divisions on its circular scale. So therefore, the least count of the screw gauge is the pitch divided by the number of divisions on the circular scale. So pitch is 0.5 millimeter divided by number of divisions on circular scale, that is 50. So that will be 0.01 millimeter. Therefore, the main scale reading is this. So therefore, the observed reading here, actually the zero error is not told. So therefore, we have to take it as 0 only. So therefore, the diameter of the wire, diameter is the main scale reading plus the circular scale reading, main scale and circular scale reading into the least count that we should take. Circular scale reading, okay. So the main scale reading, that is 1.5 millimeter, plus the circular scale reading, that is 7 into the least count, that is 0.01 millimeter. That will be 1.57 millimeter. 1.57 millimeter. Now therefore, the curved surface area of the wire, that is equal to pi dh, pi dl. So pi is 3.14 into d, that is 1.57 millimeter. Answer is given in centimeter square, so you should convert into centimeter. So that is 0.157 centimeter. So this is 0.157 centimeter into the length, that is 6.8 centimeter. So the answer should have least number of significant figures, which is 2. Answer should have least number of significant figures, which is 2. So this I can tell pi, this is actually, this I can tell pi by 20, since pi by 2 will be 1.57, so pi 10 into 6.8. So this is like approximately pi square by 20 into 6.8. So this is a centimeter square. So pi square into this will be 2 3 are 6, 3.4, so 0.34 centimeter square. So pi square is approximately 10, so it is approximately 3.4 centimeter square. Since pi square value is approximately 9.86 approx. So it is approximately 10, I can say. So 10 into 3.4 is approximately 3.4 centimeter square. So option B is the correct answer. Then it is told the maximum error in the measurement of resistance, current, and time for which current flows in an electrical circuit are 1%, 2%, and 3% respectively. Okay. So here it is told that the maximum error in the measurement of resistance, current, and time for which current flows in an electric circuit are this. The maximum percentage error in the detection of the dissipated heat will be. So the heat dissipated, that is given as I square R into T, which is the Joule's law of heating. So therefore, the maximum percentage error in the measurement of heat, that is change in heat, that is delta heat by heat into 100%, that is equal to 2 into delta I by I into 100, that is equal to the percentage error in the measurement of current plus percentage error in the measurement of resistance plus the percentage error in the measurement of time. So therefore, the maximum percentage error in the measurement of heat, the maximum percentage error in the measurement of the dissipation of heat, that is equal to 2 into, for resistance, that is 1%. So this value is 1%, this value is for current, that is 2%, this value is 3%. So it is 2 into 2%, 2 into 2% plus 1% plus 1% plus 3%. It is 4 plus 4, that is 8%. That is 8%. So option D is the correct answer. And here it is told if momentum, area, and time are taken as fundamental quantities, then the dimensional formula for the coefficient of viscosity is. So as you know, the coefficient of viscosity, that is given as the viscous force divided by 6 pi r into V. Now, viscous force, I can say that is its dimension of, so it means the dimensional formula for coefficient of viscosity, that is the dimensional formula of force by the dimensional formula of radius into dimensional formula of velocity. Now the dimensional formula of force is same as momentum by time by the dimensional formula for r into v, so it is r square by t. Since v is length by time and r is also the radius is also a type of length only. The radius is also a type of length, so I can say r into v is L square by t, and L square is same as the dimension of area. So coefficient of viscosity dimensional formula is momentum by time into this time into time divided by L square, which is area. So this will be momentum by area. So it will be P a power minus 1 t power 0, since time will get cancelled. So this will be the dimensional formula for coefficient of viscosity. So option A is the correct answer. And here it is told n main scale divisions coincide with n plus 1 vernier scale divisions. So the least count of vernier calipers when each centimeter of the main scale is divided into 5 equal parts. So it means that 5 main scale divisions, that is equal to 1 centimeter, since 1 centimeter is divided into 5 equal parts on the main scale. So one main scale division, that is equal to 1 by 5 centimeter, which is 1 by 5 centimeter, and one vernier scale division, that is equal to n by n plus 1 main scale division. Now therefore the least count of the vernier calipers, that is 1 main scale division minus 1 vernier scale division. So that is 1 by 5 centimeter minus n by n plus 1 times the main scale division, which is 1 by 5 centimeter. So this will be equal to 1 by 5 into 1 minus n by n plus 1, which is equal to 1 by okay. Okay. N plus 1 minus n. So it will be 1 by n plus 1, 1 by 5 into n plus 1 centimeter. And if you convert it into millimeter, then therefore the least count we got, that is 1 by 5 into n plus 1 centimeter, which I can say it is 10 by 5 into n plus 1 millimeter. So that is 2 by n plus 1 millimeter. So this is the least count. So option A is the correct answer. It is told the SI unit of a physical quantity is Pascal second. The dimensional formula of this quantity will be. So Pascal second, it means that it is pressure into time, means it is force into time by area. It means its dimensional formula will be mlt power minus 2 into t divided by area, which is L square. So this will be ml power minus 1 t power minus 1. So option A is the correct answer. And here it is told a silver ware has a mass 0.6 plus or minus 0.006 gram. A radius is 0.5 plus or minus 0.005 millimeter, and length 4 plus or minus 0.004 centimeter. The maximum percentage error in the measurement of its density will be. Now therefore density, as we know, that is equal to silver ware. So it is obviously a cylindrical ware. Its length is L and its radius of cross section is R and its mass is M. So density is mass by volume. Volume is pi R square L. So therefore the percentage error in the measurement of density, which is delta rho by rho into 100, that is equal to the percentage error in the measurement of mass plus twice of the percentage error in the measurement of radius plus percentage error in the measurement of length. So this will be equal to 0.006 by 0.6 into 100% plus 2 into 0.005 by 0.5 into 100% plus this will be 0.04 by 4 into 100%. So therefore, the percentage error in the measurement of density delta rho by rho into 100%, that will be equal to, now this value, this will be, this we can take point here, so 6 and 6 will cancel, so this will be 0.01. 0.01 into 100, this is 1, this will be 1%, 1% plus this will be point, I can take it here, so this will be 5, 0.01 into 100, that is 1%, so 2 into 1%, and plus this will be also 4 into 0.01 into 1%. So all percentage errors are 1%. So this will come 2 plus 2, that is 4%. So 4% is the maximum percentage error in the measurement of density. Option A is the correct answer. Then here it is told the dimension of mutual inductance is the dimensional formula for mutual inductance. So as you know, phi b is equal to m into I. So phi is the flux, or we can say phi b is the magnetic flux, or we can say that minus m di by dt, that is equal to the potential difference. So the potential or the EMF induced, that is equal to minus m di by dt, where let's say m1 is the mutual inductance. So it means the dimension of mutual inductance, that will be same as the dimensional formula of voltage into time by current. Now voltage equals to work done by charge. Voltage equals to work done by charge. Now charge is equal to I into T into I into T. Now work done is force into displacement, force into length into this current. No, this is time, sorry. So time and time will get cancelled. So force into length divided by I square. So therefore, the dimensional formula for mutual inductance, that will be equal to yeah, which is the work done by current square. The dimensional formula of current work done by current square, which will be equal to force, that is mlt power minus 2 into length by current square, so which is ampere square. So therefore, the dimensional formula for mutual inductance, that is equal to m L square a power minus 2 t power minus 2. M L square t power minus 2 a power minus 2. So option C is the correct answer. Here it is told if z equals to a square b cube by b power 3 by c power 4, then the relative error in z will be. Now relative error in z means delta z by z. So that will be equal to 2 delta a by a, which is the twice of relative error in a plus 3 times of relative error in b plus 4 times the relative error in c. So 2 delta a by a plus 3 delta b by b plus 4 delta c by c. So option C is the correct answer. And here we know that error should always be added and error should never be subtracted. So we should always add the errors. We should always add the relative errors, we should not subtract the errors. So option C is the correct answer. So hope all of you have understood. Still any doubts if you have, please write that in the comments section, and please install our Sapience Education application, whose link has been provided in the description, where we shall upload some important homework questions based on the previous year questions on JEE mains on every chapter of physics. Thank you. So thank you everyone. Bye.